Hello, today we're picking up from where we left off in the last video. This is Basic Statistics 3. We're going to be displaying and summarising the data that we've just cleaned up. For this you will need SPSS 19 as always. You will need the data file laphernia.sps, which you should have saved after the recoding in the last exercise. There's core reading associated with this video, and it's chapter 1 of Statistics at Square 1, which is in your e-library. Today we'll be displaying summaries of continuous and categorical data and what continuous and categorical data are. We'll be discussing the Fivenumber summary and why this is useful. We'll be looking at histograms and leading on from that to talk about the normal distribution and how this is fundamental to frequentist statistics. The functions that we'll be using are frequency and Plot. We may get onto something else, but we'll see. So if you open laphernia.sav, not SPS, I said that wrong, SAV, this is where we left off. The first thing we're going to do is get rid of the old gender variable. Now, there's lots of ways to do this, but with a big data set, the easiest and quickest way is to resave the file, but now click Variables, and this allows you to select the ones to save, so you want to unclick gender, continue, and save, yes, and then you want to reopen, revert to save, and now you've reopened the file without that old variable. So, as we did before, we want to go to Analyze, Descriptive Statistics, Frequencies. We're going to start by looking at just the continuous variables. So that you'll see this is what we set up in the variable view at the start, that age and pain score have the tape measure beside them, which tells you that they are descriptive, and those three circles are grouped data, categorical data. So scoot across the continuous variables, unclick Display Frequency Tables, because we don't need that anymore. Go to Statistics, and as before, quartiles, mean, minimum and maximum. But this time go to Charts and click Histograms. And you can click Show Normal Curve in Histogram as well. Click OK. So I mentioned in the introduction the Fivenumber summary. The Fivenumber summary is the minimum, the lower quartile, the median, the upper quartile, and the maximum. And that's displayed in SPSS in the statistics box, which is in the frequency output. Percentiles 25, 50 and 75 you can read there. That's another way of saying the lower quartile, the median and the upper quartile. And it's useful because it tells us exactly what these numbers mean. Why is the Fivenumber summary useful? It's useful because it tells us about the distribution of our data. What do we mean by distribution? Well, if we take age as an example, we have a minimum of 32 years and a maximum of 99 years. So we have a number line between 32 and 99. And on that line are 100 patients distributed according to their age. If we look at the median, so that's what's represented by 50 in percentiles, the median is the centre of the data, and that corresponds with an age of 61. So below 61 lies 50% of the patients, and above 61 lies the other 50%. The lower and upper quartile represent similar ideas. So the lower quartile is at the 25% mark. So at age 50, below this lies 25% of the patients between the age of 32 and 50. And similarly, below 76 and a quarter lies 75% of the patients. So these numbers, this Fivenumber summary, gives us a lot of information about the distribution of our continuous variable in our sample. If our data are spread out evenly along the line, then you would expect the distance between the lower quartile and the median, that's the 25 and the 50, to be similar to the distance between the median and the upper quartile, that's between the 50 and the 75. And you can see between 25 and 50 the difference is 11, and between 50 and 75, between the median and the upper quartile, the distance is 14 years. And that is not dissimilar. And that takes us on to this idea of the normal distribution and skew. Skew is when the data are asymmetrical. So, move on down to the histogram. This is a histogram of age, and this is a graphical summary of the concepts that we've just been talking about. It tells us how many patients in our case there are in each group. So you'll see in this example that there are 4 bars between 40 and 60. So each bar represents 5 years. So between 40 and 45 there are 2 patients, between 45 and 50, 6 patients, and so on. This can be changed. We chose to superimpose upon our histogram a normal curve. I'm sure most of you have come across the concept of the normal distribution before. It's of fundamental importance to statistics, and it's very important that you know how to look for it and what that means. When analysing continuous data, there really are 2 approaches, and we'll come on to this in a lot of detail. But those 2 approaches, either non-parametric or parametric, rely on whether your underlying data is normally distributed or whether it can be made to be normally distributed. So in this case, looking at age is normally distributed in our group. Going down to look at pain score also is pretty normally distributed. But what if it wasn't so straightforward? I'll show you another plot which is a much better way of comparing the distribution of your data with, in our case, a normal distribution, but ultimately any distribution. To do this, you go to Analyze, Descriptive Statistics, QQ Plots, and that QQ stands for Quantile Plot. Select your 2 continuous variables, scoot them across. Make sure that the test distribution is normal. There are other options. And click OK. This is what you should see, a normal quantile plot. This one's of age. It has a line at 45 degrees going from the bottom left hand corner to the top right hand corner, and circles representing each of your patients. On the x-axis is the observed value of age going from 32 to 99, and on the y-axis is the expected value should your data be normally distributed. So the closer your lines are, the closer your dots are to this line, the more normal your data is. So this data is very normal. What you're looking for is particularly at the extremes, at the top of the line and the bottom of the line, the values, your patients curving away in either direction from the line. There's a second graph, detrended normal quantile plot of age, and this is really putting the line on the horizontal axis and zooming in a bit. And this just gives you the same information but in a more detailed form. And so this tells us that our data follows a normal distribution. Similarly, if we look at pain score, it's also normally distributed, which is great because it's going to make our analysis of it much easier. Okay, I just want to quickly show you how to make a histogram without using the frequency function. Going to Graph, Chart Builder. This gives up a warning that says you must make sure that your variables are accurately labelled scale, continuous or categorical, which we know we are. So we'll click OK. So this is the Chart Builder box. We can click on Histogram down here. We want just a simple normal histogram. So drag that into the box, and we want to look at age, so drag age into the x-axis. We could click OK, but earlier I mentioned bin size. Sometimes you might want to change the breadth of your bars. You do that with set parameters, bin sizes. I've included on the page a second file called skew.xls. This has, and I want to make the interval width, the breadth of my bar, 4 years this time rather than the 5 it was last time. Click apply, click OK, and then if you look in the output window, you have a new histogram, this time with smaller bars, each representing 4 years. I've left a second file on the website called skew.sav. I'd like you to load this up, and in it you will find 3 age distributions. Make histograms and QQ plots and tell me whether they're normally distributed or not. If they're not, how would you describe them? Thank you.